Hello everyone, welcome to MiEduBrand Academy, Midnapore. Now we discuss about JECA mock test on computer networking. So first question is unipolar, bipolar and polar encoding are types of DES encoding. You have 30 seconds to answer in the comment box. Please answer this question. You can answer this question in the chat box, live chat box. Yes, the correct answer is line coding. Line encoding technique where line encoding technique is divided into unipolar, bipolar and polar encoding technique. So there are three types of line coding. One is unipolar, second one is polar and third one is bipolar. Okay, so we moved into the next question. Please answer this question. You have 30 seconds. Please answer this question in the comment section. If a symbol is composed of 3 bits, then there are base data level are available. Everyone please answer this question in the comment section. The right answer is 8. Option C. How? The relationship between bits and data level, if we consider data level as L and bits as N, then L equal to 2 to the power N. Here we have 3 bits available, so N equal to 3. So number of data level L equal to 2 to the power 3, which is 8. 8 is our correct answer. Good job, Shravan. Everyone should answer it. So we moved into the next question. Question 3. Answer this question. Pulse rate is always dash the bit rate. Answer this question in the comment section. Please answer first. The right answer is of the question 3 is option D. How? Let's explain it. So the relationship between pulse rate and bit rate is bit rate equal to what? Pulse rate multiply by log L base 2. So the bit rate is always greater than or equal to pulse rate. So reversely we can say that pulse rate is less than or equal to bit rate. When equal to will happen when the log L base 2 is equivalent to 1, then bit rate equal to pulse rate, or pulse rate always less than bit rate. Clear? Next, question 4. Base encoding has a transition at the middle of each bit. Answer this question in the comment section, please. Coil answer it. Anyone can answer it? For the question asked, base encoding has transition at middle of each bit. That means we if we have a amplitude and frequency domain or amplitude or time domain, then 4010, the transition is taken as a middle of each bit, like this. Right answer is option D, all of the above. Because in return to zero, we transit at the middle of the each bit for Manchester and different Manchester. Both are similar types, and we transit of middle of each bit. So right answer is option D. Clear? Next, answer the question 5. This encoding has a transition at the beginning of each bit. Answer in the comment section, please. So the right answer is option C, different Manchester encoding technique. What happened in different Manchester encoding technique? In different Manchester encoding technique, for the first bit, it change its direction. That means positive to negative or negative to positive. And in different Manchester encoding technique, if we give 0, means transition, and 1 means no transition. Okay, and at the very of the beginning we transit it, that means positive to negative or negative to positive. All clear? Answer question 6. PCM is an example of dash conversion. Digital to digital, digital to analog, analog to digital, or analog to analog. Answer in the comment section, please. What is the full form of PCM? I will give you a hint. PCM means, please answer the full form of PCM in the comment section. Anyone answer it? PCM is stand for pulse code modulation. What is the right answer? Analog to digital. Option D. Very good. Coil is right. Sabon is right. Momita is also right. Analog to digital. Answer question 7. If the frequency spectrum of a signal has 500 Hz bandwidth. So what is the bandwidth? 500 Hz. With the highest frequency is 600 Hz. What should be the sampling rate according to the Nyquist theory? Answer it in the comment section, please. Just remember Nyquist theorem for sampling rate. We have two Nyquist theorem. One is for bit rate, one is for bit rate, and another is for sampling rate. Just remember the second one, sampling rate of Nye's theorem. According to Nye's theorem, the sampling rate is 2 times of highest frequency. This is the formula. So 2 into what is the highest frequency? 600 Hz. Just multiply it and our answer is 1200 Hz. So the right option is D. Clear to everyone? If any doubt, you can ask in the comment section, please. Next question. Question 8. The Nye's theorem specifies minimum sampling rate to be dash. We have answered this question in the previous question. What will be the answer? Answer in the comment section very fast. Don't confuse by the minimum sampling rate. What will be the answer? Quick, quick. Very easy. Yes, twice of the highest frequency of the signal. Twice 2 multiply by HF, that means sampling rate. Is it clear to all? We just explained it in the previous question. See, sampling rate equal to 2 into highest frequency. So go to the next question. Question 9. One factor in the accuracy of the reconstruction of PCM signal is the dash. Answer in the comment section very fast. Accuracy depend on. Yes, the correct answer is C. Number of bits used for quantization. If you memorize the PCM signal, the analog signal was as it is, and for quantization we just take the peak value, so like this, and so on. So if you use more than number of quantization is more, then like you can divide more than quantization here, then the signal give accuracy. Clear? So now move to the next question. Which encoding types always has a non-zero average amplitude? Non-zero average amplitude. What is the mean of the non-zero average amplitude? That means the positive voltage is not neutralized by the negative voltage. Or we can answer it in the reverse direction, like negative voltage is not neutralized by the positive voltage. In which encoding technique it will be happened? Answer it very fast. Yes, Rakesh was right. Unipolar. Very good. Next question. Which of the following encoding method does not provide for synchronization? Does not provide synchronization. Answer it in the comment section very fast. The right answer is NRZ L. What is the full form? It non return to zero. NRZ NRZ non return to zero. L for level. Okay. Now next question. Question 12. Answer it. Which encoding method used alternating positive and negative value for 1? Very easy. When we read it at the last technique, anyone remember what was the last technique we read it? The last technique was bipolar. Is it? But bipolar is not in your option, yeah? So the alternative name of bipolar is AMI. What is the full form of AMI? Alternate mask inversion. AMI. Alternate mask inversion, which is the another name of bipolar. Clear to all? Next, again question from PCM. Pulse code modulation. In PCM, an analog to dash conversion will occur. Very easy. Answer very fast in the comment section. Yeah, Coil was right. Sahani also right. Analog to digital conversion. Next question. Question number 14. If the maximum value of PCM signal is 31, PCM signal maximum value is 31, the minimum value is minus 31, how many bits were used for encoding? PCM, pulse code modulation, maximum value is plus 31, minimum value is minus 31. Can you count how many number of value that this range is covered? That means minus 31 to plus 31. So minus 31 minus 30 minus 29 and so on 0, then plus 1 plus 2 and so on. So how many value range is covered? How many? Near about 63 including 0. So number of value is 63. For 63 value cover, how many bit required? We need 2 to the power 6. 2 to the power 6 equal to 64. So under the 64 we can cover 63 value. If we take 4 bit, then how many value we can cover? Just 2 to the power 4, that is 16. If you take 5 bits, then we cover total number of 32 bit. If you take 6 bit, then we can cover 64 bit, 64 values. And if you take 7 bit, we will cover 128 values. So here both options are correct. We need total 63 value needs to cover. So option A is not possible to cover 63 value. Option B is also not possible for cover 63 value. But option C and option D both are covered 63 value. But we need to answer accurate answer from the C and D. C is the accurate answer. If you take C option, then you only lose 1 bit as extra bit, 1 value as extra value. But if you take 128 values, then you probably take how many? 65 near about extra value. Okay, so most accurate answer is option C. If the answer given in this format, like both C and D, so it will be the most accurate answer than C or D. Okay, this type of answer can be formatted as a option. Okay, next question. Is it clear to all? Next question. Question number 15. RJ. What is the full form of RJ? Return to zero encoding involves this signal level. How many signal level in return to zero encoding technique will used? Yes, 3 signal level. The right answer is 3 signal level. Next. Option 16. Question 16. Which quantization level result in the more faithful reproduction of the signal? Quantization level. What we learned from the previous question, that number of quantization level is increased, then accuracy is increased, more faithful, that means more accurate production. What will be the answer? Option? No. Option D. 32. Next. 17. Answer it. Which encoding technique attempts to solve the loss of synchronization due to long string of OS? Zeros. Long string of zeros. Answer it. The right answer is B and Z. This is out of syllabus question. You can ignore it. Just remember. Next question. Block coding can help in days at the receiver side. Synchronization, error detection, attenuation, or both A and B. That means synchronization and error detection. Answer it in the comment section. The right answer is option D. Block coding we use for synchronization as well as error detection. What is the previous version of block coding? Line coding. Is it line coding? So in line coding, we only synchronized the signal and remove the DC component, and after involving block coding, we also do extra things like error detection. Concept clear to all? Next question. Question 19. In this transition, bits are transmitted simultaneously, each across its own wire. This is serial transaction. Serial have two classification. One is asynchronous serial transmission and another is synchronous serial transmission. And this is the parallel one, and this is the transmission. Transmission classified into two categories: serial, parallel. Serial have two classification: synchronous and asynchronous. Answer it. Shravan, answer is option A. Why option A? Beats are transmitted simultaneously. Yeah, the right answer is option C. That means if you have 4 port for in sender section and 4 port in or station in receiver section, then each port send the data independently, simultaneously. Okay, if the data is sent one by one, then it comes to serial transmission. Concept clear to all? Next, question number 20. In dash transmission, bits are transmitted over a single wire, one at a time. Yeah, the right answer is option D. That means serial transmission. So serial have two classification. That means both are under the serial transmission. So option A and B is correct answer. So the right answer is option D. Question number 21. In dash transmission, the start bit and stop bit, it is bit is required for each character byte. Answer it. Start bit and stop bit is required. That means bit padding. Bit padding is required. In which technique? Coil answer B. Why? Why answer B? Synchronous serial transmission. That means sender and receiver both have equal sending speed and receiving speed. So we do not need bit padding technique here. When the sender and receiver both have asynchronous, that means the sending speed and receiver's receiving speed is not matched. In this case, we use bit padding to make it integer multiplier for synchronization. So where bit padding is required for synchronization. In asynchronous transmission. Concept clear? So the right answer is option A. 22. Answer it. In asynchronous transmission, the gap time between bytes are days. What is means by the gap time? Gap time. gap time, time between two bit. That means sender, receiver. If you send one bit and one bit is reach at the receiver section and you send another bit as 0. So the time between sending one bit and wait to sending another bit. This is the gap, gap time. This is the gap time. So in asynchronous transmission, asynchronous, that means sender and receiver have not in the same synchronous speed. So here the time between two bits are fixed or variable. Variable, clear? Yes, B answer. Next, question number 23 and the last question of this session. Everyone should answer it. Synchronous transmission does not have this. Synchronous, that means sender and receiver both understand each other speeds. Is it need start bit? Is it need stop bit or gap between bytes? Nothing is required for synchronous transmission. Does not require. So all of the above. All of the above, like a start bit, a stop bit, and gaps between bytes is not have in synchronous transmission. Okay, this three is only present in asynchronous transmission. Clear to all? In synchronous we do not need it. Okay, so the right answer is option D. And if you want to prepare for JECA 23, you should contact our academy. Our offline class is going on and this is our contact number. You can contact us in any time. Our branch is in Midnapore, Keranitola. So this is our today's session. We will take another mock at tomorrow by 9 p.m. So good night to all.